as usual, I don't believe philosophy is there to just talk about philosophers who talk about philosophers who talk about philosophers, in a regress. I think really what philosophy is at its best when it begins with an issue, and I think it begins with an issue that ideally, and I find issues very suspect if you can't frame them in ways that an ordinary person could understand prior to philosophical training. If it becomes too sophisticated, I start to worry that it's just an academic game. And unfortunately, you may have spent a lot of classes learning academic games, and you sit there wondering, like, who the hell cares? And it's true. If it's just a bunch of intellectuals talking to one another, but there's no condition under which anyone could decisively be shown wrong, and what tracks good and bad views is just the approval of that small little community of that priestly class who's just talking to one another in a circle, I don't think that's the right way to do it. So I like beginning with a problem, and this is some orientation that's broadly what we call pragmatist. And I want to get a handle on the problem first. Here's well, whatever this is, like an orange thing. All right, here this comes. Here it comes. Pay attention. All right, where's the red circle? Straightforward answer, straightforward question. We're just warming up. Certainly not visible anywhere. It's behind or in it. I'd say it's behind the rectangle, right? That seems like a decent answer, right? Or like if it was a box, like it kind of rolled into the box or it went behind the thing, right? And I don't get a lot of. I mean, it's a no-brainer answer. If again, remember where my starting point, right? So let's redo this again. So remember, I start with just like common sense because we're going to start with common sense. So here we go. Let's have a look at this again. Here we go. Here it comes. Here it comes. Here it comes. All right, Tristan. Here you go. So where is it? Where's the red? Let's ask again. Where's the red circle? Yeah, it's behind the rectangle. Yeah. And again, this is an answer that's I think like in many ways correct. And if I were to ask this, and it's interesting if you have a group of philosophy students, they'll always think there's a trick to anything, and they're always concerned to not answer or answer something more sophisticated because they're scared there's a gimmick, and it kind of maybe is. But the point is, common sense wants to say that it's behind. And if I were to ask this to I think everyone, most people, by and large, let's say you take 99% of the Earth's population, I'll say it's behind it, and with good reason. And why is that? Well, I mean, if you think about it, this is something that we acquire. What I'm showing you is what we call visual stimuli, right? So I just showed you visual stuff. When we're young, our eyes develop. At the beginning, when you're a newborn, everything is out of focus. And I can see this because I've had newborns and they're very confused. And your eyes, just literally the muscle that contracts your eye over here, just literally aren't developed enough yet. And you don't know what to track. But as you get a certain age, and this starts actually really, really, really young. This actually is a kid, it's pretty old. You can start these experiments where you mount these machines, and you can use this also non-invasively. You don't even have to wear this kind of stuff. You can have like a monitor that's looking down on a crib, and just like you have, those things that hang over the crib for the babies. What are they called? Those a mobile. Yeah, kind of like a mobile. You have this hanging over the baby in the crib. The baby's lying on their back, and you can look at their eyes. And you can offer them different visual stimuli. In this case, for instance, if you see here, this would be the visual stimuli. So you see here, that's the scene camera. That's what you're giving objects to this child, whatever, right? But this could be like visual, tactile and visual, just visual. I mean, you can have fun with this stuff combined with auditory stuff, right? And then you can look at the eyes over here. You can track where the eyes are looking, right? And you can know specifically, just like on my red dot, like the child was looking here, the child was looking there. You can also look at the degree of pupil dilation, right? And what's interesting is that if you have these machines and you basically present a child with like a young neonate, so like a newly born child, with this visual stimulus at a certain age, they're just looking, right? And they're all over. So like you see, does everyone see my small red dot? If you can see it, type in yes. Like just that's my little red dot thing. Yeah, I just moved it now, but here you go. Their eyes are like this. They're darting all over the place. This is at a certain age. And in fact, or they're just kind of blindly staring in front of them. That's really, really young, right? When their eyes start to develop, then they're kind of like, pretty much there's no sense to what they're doing. Their eyes make no sense. So if you were to track this, imagine it leaves an after image, right? Their eyes are going like this and like this and like this. And you can calculate this in real time. So time T1, time T2, time T3. This gets like, it makes no sense, right? And then you give them this pattern. Eventually, especially as they begin to develop their motor skills, so that is as they begin to see more objects in the world and or start to develop their motor skills, that is they start touching things, but also have a greater sample of things they've looked at. When you do this and you have a stimulus that looks like this, their eyes start to go over here. The eyes are going over here. The eyes are darting over here because they're expecting this shape to come out the other side, right? They're starting to form basic fundamental concepts about what it is to be a thing. Things that have like properties such as being behind, in front of, they're opaque, they block one another and things of that nature. Their eyes are darting there, and you can track all of this. You can literally see at what point they're going there, right? And they're expecting this to come out on this side. And that expectation, normally if you're dealing with things, is fulfilled. But we're not dealing with things right now. We're dealing with visual stimulation. Really all we have right now are two-dimensional colored shapes. Really. I mean, it's really easy for us to think in terms of this red thing as some sort of ball rolling and this orange thing as some sort of a plank of wood, if you will. But strictly speaking, I could do whatever. If I did this, for instance, if what comes next is this, right, and out comes, let's say, a green triangle, their eyes would go here, right? So it would dart. You'd see all the way. It would dart from here to here in a flash. And moreover, not only would it dart there in a flash, there would be really significant pupil dilation. Like this black area here would be very large because that's when you're surprised. For good reasons, evolution has beaten into us that when you're surprised, you want to take in as much information as possible to prepare yourself for what you're going to do next. And one of the ways in which you get more photons into your eye is to just open the valve a little larger, right? So your pupils dilate. Actually, what happens is your iris here shrinks. It's a little muscle that shrinks. The pupil doesn't technically dilate. It's the iris that shrinks. That's the part that moves, if I understand my biology correctly, and I'm pretty certain I do, although I might be wrong with this stuff, but I don't care. It ends up, you take in more photons. And the kids also, if you had to look at their bodies, they tense up as well, right? Blood pressure goes up, and there's an element of surprise because with an expectation comes the possibility of frustrating that expectation. Right. So this, once you've formed an expectation, once your eyeball was going over here expecting it, like once it came in here, then the next eyeballs were going here waiting it for coming on the other side. This soothes your expectation. This satisfies your expectation. It's concordant with the habits that you're taking on. And if you do epistemology with me and we do, let's say, my third year level course on Charles Sanders Peirce, you'll recognize a lot of this talk about habit as kind of the foundational notions in this epistemology. But if you have an element of surprise like this, right, all of a sudden now you adopt this posture of readiness because you don't know what's going to happen next, right? And the moment you do this, it's indicative that you're starting to acquire, I mean, here's the pupils dilating. The moment we have evidence that you've got this, even if you can't verbally speak yet, this is why the eye tracking is interesting. This is something that can be done developmentally way before the acquisition of language. So it's not like you have to ask a questionnaire and wait till the child is capable of language to tell you what it is that they think. You can infer what they think. You start building what we call folk physics. And folk physics are things that even apes, non-human apes have, right? And you might say a folk metaphysics, right? A theory of what we would call Aristotelian substances. In this case, you're starting to develop the notion of a thing, right? And you can think of, we all have a folk metaphysics. And the folk metaphysics, interestingly, fits quite well, and there's a reason why 99% of the population would say, let's say, that the red circle is behind the orange thing, is because we all share, in some level, a folk metaphysics. There's a certain common sense view of reality that we have, but as with most things that are critically unexamined, could be right, could be wrong, but we have no way to tell. It's mainly useful for dealing with mid-sized ordinary objects, but when it comes to explaining other things, we might have some problems. And we're going to look at a case of causation right now. So I want us to understand we have a folk metaphysics. That's what you were turning to when you answered it's behind the thing. It's like, strictly speaking, there's no behind anything, right? That's not the problem yet. That's not the problem. That's just me table setting for the problem. It's just a bunch of pixels. Yeah. I mean, yeah. So I mean, like, it's not, nothing's happening behind. I mean, if you look here, right? You have a geometric shape, and here you have a geometric shape. It's like, why do you have any evidence for what's behind? So just to sort of problematize this a little bit for Francisca and everybody else, visually, Francisca, let's call this area A over here, right? This hypothetical area. Strictly speaking, if you look at what we have on the screen right now, short of my writing, do you have any visual evidence for A? Yes or no? Strictly speaking, you look at this image. No, exactly. There's no evidence for this, right? This part A, whatever it is an expectation. You have present visual evidence for, well, it's not, I'm on red right now, so it won't show, right? You have present visual evidence for B. You have present visual evidence for C. But A is an inference. B are premises, A is a conclusion. B and C are premises, right? So essentially what you have is like, well, you have B, right, and C at like time t1, right? I'm going to put subset 1. And you have B, right, at time t2, and you have C at time t2. And look, it didn't actually move. C, it turns out, is a constant at time t1 and time t2 and so on. Dot, 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 you keep on going. Therefore, conclusion, and then you conclude something. This is what we call an abductive inference. It's more risky than what the premises actually permit you to do, right? And then you infer as a conclusion, right, that there is this space A going all the way to here. I mean, when it's here, right, we reach a stage where you're assuming, and you got no real grounds to think this. Yeah, you actually, you don't see, Francisca. I see. No, you don't see. I know, exactly. Sweet. So now, and there's that hypothetical thing that we're all positing there. And of course, and if you study Kant, and unfortunately no one teaches you Kant well, this is what worried Kant to no end, right? When we have a metaphysics of any sort, we go beyond experience. I mean, it's strictly speaking, we go beyond experience. What the hell permits that? This would be the greatest segue into Kant if we wanted to do a deep dive in that, right? What permits metaphysics is an account of the world apart from your cognition of it. That's a tricky thing, right? And the fact that it's a folk one, the fact that we acquired it early on, and the fact that we, let's say, all converge on it in our folk metaphysics, that you can track that we would all, irrespective of where we were born, let's say if you were in Indonesia, who the hell cares? You'd be surprised when if the triangle, after a certain while, this what I've just said about, like, at the beginning you're a vegetable, you just track, your eyes are going here, then eventually you're all over the place, right? And then eventually you reach a stage where your expectations are over here, and then if you're surprised, you're over here, and your pupils dilate. That applies all across the globe, right? It's not culturally specific. It's not learned. It's learned, but not culturally learned. It's learned from experience and your engagement with things and visual stimuli, right? And the fact that we're all equipped with that, that's the starting point that I have in this class, that, anyone who wants to do metaphysics has to start with folk metaphysics. Because remember what I said in the very first week, if philosophy is something that everyone has. Everyone has an answer to the questions, what is there, how do I know it, and what should I do? Everyone, including a little baby. The only difference is, can you verbalize it? Can you analyze it? Can you open it up and check what's under the hood, right? That's the only difference, but you got to start from where you start, and where you start is with your folk metaphysics, right? And here again, we have an instance of folk metaphysics, right? So here's a familiar sort of phenomenon, right? Here we go. This is something you could observe, and this is, you don't have to be a neonate lying on your back. And then what's going to happen next, given everything I've shown you? What's the inference that you draw? So let's say those were visual premises. What's the conclusion you're going to infer? What are you predicting? What's the prediction? What's going to happen? Yeah, it's going to move to the up and right. Exactly. And just, not only will it move, it'll move in a specific fashion, right? What about 8? Will 8 keep moving? If you've done some billiard, depends, but chances are it'll reduce, right? At any rate, depends on the spin, agreed, but it certainly won't keep going in a straight line. I mean, the surprising thing here would be if, let's say, 8 kept phasing through 5 and 5 would stay right where it was, then trust me, your eyeballs would go woo, right? You're playing billiard balls with your friend and you're wondering if you took too much cannabis, right? But the inference is going to be that the following is going to occur, right? This is going to happen, something along these lines, right? These are just sort of artificial slides I made. I gave a spin to kind of make it more realistic. There we go, right? This is what you would expect to happen. This is what you would expect to happen. And now we're going to reach some interesting questions. All right, so here's a problem. So remember earlier what I said, strictly speaking, so let's go back a little bit, right? Let's do the eye of Agamotto here. Let's go back. I said a moment ago, go back, that strictly speaking, we don't have any evidence for that circle behind. I was joking with Francisca. I see, right? No, you don't. You have no evidence for all of this. You have no evidence that, let's say, it's behind. Strictly speaking, you have no evidence for this. When you get to the cause, when you get to the situation that I was looking at, this other scenario, right? When you get to here, and you got this situation here, which is, by the way, again, a situation anyone can observe, right? Here's the thing. You're going to want to posit this to explain what's going on. So in addition, by the way, the sort of experiences that you have aren't just visual. You might hear a sound. If you're looking at real billiard balls, they make this clacking sound, right? And you want to posit something if you want to explain why your inference was correct, because you basically inferred from premises to a conclusion, and you want to know, well, what explains the success of that inference? You're going to say, well, something happened there. I'm going to say, what happened? And you say, something called causation, right? You're going to want to say that the reason why 5 started moving in an upright, so upper right direction is because 8 was going and hitting it also, right? So the movement of 8, the events leading up to it, are explain the movement of 5, right? But again, strictly speaking, here's the thing, strictly speaking, right? All you have is this experiential input, visual and or auditory. You can add a clacking noise if you want. The extra step, and again, this is very Kantian, the extra step that goes beyond your experience is to posit something like causation. But you don't ever actually see causation, ever. And this is the troubling part. This is where, we need to kind of be reminded of this by philosophers. Because when we have our folk metaphysics, it becomes such second nature to us. We're so accustomed to seeing the world that way and to being comfortable with deposits that we've made that extend beyond what we visually or auditorily or tactily experience, right? That we're comfortable thinking, yes, of course they exist, right? This is a thing in the world. And what are the ingredients in your folk metaphysical account of reality is something called causation. But strictly speaking, I or no one else has any evidence for that. All we have evidence of is that there were these events over here. Let's call this events C, subset C, because it looked like a cause, right? And then you have events over here. Let's call these events subset E, right? Events that are the effect. And that the events C happened before events E. They succeeded each other in time. That is it, strictly speaking. And so if you're at all drawn to the idea that you should basically ground your theory of reality on what's actually confirmable by the evidence of your senses, then this was a worry that crept up when we discussed abstract entities. It's a worry that crept up when we talked about possible worlds. And I think a lot of people have this demand, and I think it's a perfectly sensible demand, that if we're going to be, say, for instance, you want to say that trees exist and ghosts don't. And the reason why you want to say that trees exist and ghosts don't is because you can observe one and not the other. It's a perfectly good reason to sort of sort out your ontology, which has to start with true sentences. And you have to decide which sentences you're going to take to be true when you feed them into this Quinean machinery of ontology. You need your true sentences. But which one am I going to accept as true? Well, it's the ones that enjoy some sort of empirical corroboration. You can actually observe them. Well, if you're going to hold yourself to that standard, you never, ever have empirical evidence of anything more than this. And so the question is, what licenses us by going beyond and positing something like causation? And if something does license us in thinking that there is this thing called causation, and notice I'm biting down on there is such a thing as causation, right? So existential quantifier, I want to say that in the world, right? Things are caused for real, right? In the metaphysical sense of for real. It's not just make believe. That the reason why we're all adept at predicting the movement of billiard balls is because we're tracking something, and that something is called causation. Then I have to be able to say, how come I can talk about something so confidently, even though I or no one else can even see it? Earlier, Francesca was asking, is this the problem? Now that's the problem. Can everyone see that? All right, let me type this in. 8 caused 5 to move. Or actually, the movement of 8 caused the movement of 5. Right, so let me rephrase that a little bit. Because we're really concerned with tracking events here, not things. The movement of 8 caused the movement of 5 to move. This is as elementary a toy example of bodies in motion, and no one in their right mind is going to want to deny this, both at the level of folk physics and at the level of the most advanced physics in some sense. And so, okay, so then we want to ask as metaphysicians, what makes that true? And then I say, well, yeah, fair enough, but I know that everyone wants to assert that that's true, that 8 caused 5. But what makes that true? And you say, well, just look. Well, sorry, I looked, but when I looked, all I see is this. What you're saying is that there's this, but whenever I look, all I see is this. I don't see this supplementary third thing, which is the causation between the two. All I see is one thing and another thing succeeding each other, a succession. I see a conjunction, not a causation. Cause, right? That's where the folk physics wants to say, right? A metaphysician is going to point out, right, that strictly speaking, all we have evidence for is and. And the cause part is a victory lap. The cause part is you taking a victory lap and going a step further than what strictly speaking you have evidence to say. All you have visual evidence to say, visual, and even if it was and the sound, so you put the sound over here, right, and the sound co-occurred, it's always linked together by and. If you want to say cause, that's something more fundamental than this. And then the whole idea is going to be the ball of yarns that Samuel's going to go. It's like, well, what justifies moving from, let's put another arrow here, right? What in the world permits us, if anything, from moving from and to cause? And that's not a given. That's something you have to argue and defend. Tristan, does that make it clear? And everybody else? How do we know? Maybe you don't know it, friend. Tristan, stay open to the possibility. It's not like, how do we know? It's like, maybe you don't. Maybe there's the whole question of how do you know that it's caused? Yeah, that's one problem. But like maybe you don't. Maybe you're just, who the hell knows? You don't want to sort of judge that from the get-go. And notice, by the way, and someone, it was Emily, the conservation of momentum, right? So here's an interesting. Let's say, for instance, you have potential kinetic energy and actual kinetic energy. So let's have some fun. Let's do a little bit of really sort of elementary physics for 1 second. Let's say you have 5 units, right, of potential kinetic energy, and here you have 0. And then after a certain point, this one comes to a rest, so you have 0, right? Once it touches, let's say, once it's on the other side of this, so before it hits this causal, bang, right? It's like this. And then after it does, then there's a transfer of energy, right? And then you have, let's say, 5 units of kinetic energy, and now here you have, let's say, 0 units of kinetic energy. So the ratio, well, let's say, potential to kinetic was 0 to 5, and then it's 5 to 0, like this. Like they swap kinetic energy. Emily, is that what you had in mind? Something like this? The fact that you have, let's say, these covariances. Let me just put this on the graph. Let's say this is a column. This is potential kinetic energy. This is actual kinetic energy. And this is, let's say, ball 8, and this is ball 5, and we can make a grid over here, right? And let's say you went from having, let's say, potential energy at first was 0, and then here was 5, and then here it was 5, and then it was 0, and this describes, let's say, time t1 prior to the impact, right? And then you can have a situation here at time t2, right? And then you put the grid over here, and then again, keeping those columns constant for what they mean, right? The potential kinetic energy of 8, it goes back to rest, right? It goes back to rest. So I got to go put my 5 over here, right? It swaps around, right? Over here, and then it swaps around over here. Let's say you have that. Once again, the question that's going to be interesting for us is, do we put an and between these two states? Or do we put cause? And cause is obviously more demanding than just and. And the thing is, you have, strictly speaking, empirical evidence only for the and. All you see is this conjunction. You see things happening and something else happening and something else happening. So Tristan writes, so this is causation, and these things happen at the same time as conjunction. Well, around the same time, succeeding one another. Yeah, something like that. A less ontologically committed way of saying what's going on. Strictly speaking, that's what we have with our evidence, is the and. Something like that. You got that, Tristan? Does that make sense? Tracking the movement of energy let's say this for a second. Let's say it one more time. Tracking the movement of energy in physics, the stuff in blue doesn't solve the stuff in red. There's nothing about tracking the succession, no matter how fine-grained you get at tracking the blue parts. Nothing in there is going to solve the why are you justified in saying that it caused, not just succeeded in time, the other. Does everyone see that? That's the difference between physics and metaphysics. Physics is like, well, I'm just going to help myself to, like if you get fine-grained, like go ahead, man, take physics and, you describe that beautifully. You've got a nice way. And maybe once you got a really great handle on T1 and T2 and all of that wonderful jazz, you can even predict, let's say T3, what's going to happen at T3. So let's say further things occur and you can give yourself a story here. And let's say your predictions bear out super well. Still, none of that tells me why I should not just say and as opposed to cause. This and this and this as opposed to this caused this caused this. Let me do another check-in with everyone. Is that clear? Again, that's the goal right now, right? I really want everyone to sink in their teeth because that's not available in the chapter. Amber says, could we say that we understand that but not why? Kind of like, let's say you could say, so Amber, if I understand correctly, you could say something like physics understands that but not why. Something like this. It understands that T3 will succeed T. Yeah, okay, cool. But that's exactly why you need metaphysics. Don't you want to know why you understand that? Doesn't that bother you? Like imagine. Like suppose you do understand that, don't you want to know the why? It's a great formulation, Amber. I like that. That's like if you're at that itch, you've got that itch, you're like, why? Exactly. And the thing is, when you want to go ask the why question, not the that question, you have to put on a different hat because the tools you're going to have to figure out the stuff in red on the screen right now versus the tools you're going to use for the stuff in blue. Look, it's rigor all across the board. So whether or not you're dealing with the questions in blue and the questions in red that we currently have on the board, you need rigor. It's going to be hard on your brain, right? And it's going to require you to work with others and to bring your A game and have a good IQ. All right, agreed. But you've seen now firsthand when you've done metaphysics now, because you're at university, this is not a joke. When you're dealing with the red questions rigorously, it's not easy, but it's not the same tools either. Can everyone see that? The tools we've been using aren't the tools of physics. Like it's not obvious that you can solve this with a better description of what is being succeeded in succession. Can everyone see that? Like a bit of a sort of sense of what's our methodology here. Yeah, and Samuel says causes give you an account of why those predictions would be accurate, but then they don't say why that account would be correct, right? So that's the thing. And if you want to say, well, the proof's in the success, well, you know what? Let's say the proofs in the success can only go so far when it comes to questions of reality. And so Emily says, why can't we say that something is causation if it's repeatedly observed? Then we're good transition for our reading. We're good to go. That's where we are. That's the starting point. So Emily, what you've just written, that's the starting point of our chapter. Yeah. That's exactly where we are. That's the sort of the starting point. And Pearl says, it makes me unsure what we even mean by cause, what it would mean if not a procession of events. Exactly right. And this is exactly, we're ready to go now. So everyone has been primed because we're going to pick up smoothly and hit the ground running right in our chapter. Beautifully. Well, oh my God. Isn't it wonderful? I have you folks, converge on a concrete case. So here's our concrete case. It doesn't get more concrete than this. I kind of primed you beforehand. Let's do a brief recap of what we did, right? Primed you beforehand about what it is to have these folk expectations. And then all of a sudden, you're ready to pick up exactly where the chapter starts on your own, even if you had, let's say, hadn't started the chapter already. What Emily just wrote, why can't we say something is causation if it is a repeated observed pattern of something following the previous thing and not purely correlational? Put that on the shelf and revisit it. We're literally about to begin there. My friends, are you excited about starting the chapter?